David Can here with another question from your Hayes and Harris Math SL textbook. This is exercise 3F, question 5F. In this question, we're still solving exponential equations by canceling their bases, but things are a little bit more complicated because of this 1 and this 2. We're not going to be able to just directly cancel the bases like we've done before. We're going to have to try and be a little bit more clever. Let's see what we can find. I see a 7 to the x and I see a 49 to the x, and I see that 7 is related to 49 because 49 is 7 squared. Let's start there. All right, now I have a 7x and I have a 7 squared to the x. But as we saw before, 7 squared to the x is the same as 7x squared. You can swap them because you can do multiplication in any order. If you don't recall, the reason that these two are equal is because they both simplify to 7 to the 2x. Using index laws, you multiply the indices. And 2x is the same as x times 2. So these two are the same. All right, what does that get me? Well, now I have a 7 to the x term, a 7 to the x squared term. This is a quadratic. Let's rearrange it to make it look like a quadratic. Maybe you'll see it. 7 to the x squared, take 2 times 7 to the x plus 1 equals 0. I have a squared term, a term to the first power, and a term to the 0 power, a constant term. That's a quadratic. Not only is this a quadratic, it's a common form of a quadratic. This is perfect squares because 2 is the same thing as 2 times 1. So I have 1 squared, 7 to the x squared, 1 and 7 to the x in the middle, times 2. That's perfect squares. That means this factorizes to 7 to the x take 1 squared is equal to 0. How does that help me? Well, now I can take the square root of both sides. 7 to the x take 1 is equal to the square root of 0, which is plus or minus 0, which is just 0. That's handy. Subtract 1 to the other side, I get 7x equals 1. Oh, where do I go from here? Well, a couple of things. What could x be such that 7 to the x is 1? You might be thinking 0. And that's true. Another thing we could say is that 1 is equal to 7 to the power of 0. And now I can cancel the bases. And x, then, is 0. If 7 to the power of x is equal to 7 to the power of 0, then x must be 0.